Have you ever wondered how many dimensions exist in our universe? This question may seem simple, but it's actually quite complex. The answer isn't as straightforward as you might think, and hinges on the context in which it's asked. In the realm of physics and mathematics, the concept of dimensions can quickly spiral into a fascinating and intricate discussion. From zero dimensions representing a point, to the possibility of multiple dimensions beyond our perception, it's a riveting journey. So, let's dive in and explore the concept of dimensions one by one. Imagine a point in space with no extension. This is what we call a zero dimension. Now you might be wondering, what does this mean? Well, consider a point in your mind. It's just that, a point. It has no length, width, or height. It doesn't stretch out in any direction. It's essentially a location or position with no size or volume. This is the simplest form of dimension, and it's the starting point for all other dimensions. In mathematics and physics, this zero dimension or point is quite significant. It's the basic building block from which we construct all other dimensions. Just as a single dot can start a masterpiece in art, a single point can be the foundation for understanding complex multidimensional spaces in science and mathematics. So, a zero dimension is simply a point with no extension. It's a concept that's both simple and profound, and it's the first step on our journey through the dimensions. Now let's move a step forward to one dimension. As we venture into the realm of one dimension, we move beyond the confines of a point and into the world of lines. Picture a straight line extending endlessly in either direction. This line represents our one-dimensional space. It's a universe that has length but lacks both width and height. In this one-dimensional universe, you can only move forwards or backwards, with no opportunity to turn left or right or to go up or down. It's a rather simple existence, with only one direction to explore. However, even within this simplicity, we can find complexity. For instance, consider the concept of distance. In a one-dimensional universe, distance is simply the length between 2 points along the line. It's a simple concept, yet it forms the basis for more complex dimensional thinking. So, a one-dimensional space is like a line extending in one direction. Scene script. Have you ever thought about how a sheet of paper can represent 2 dimensions? It might seem like a simple object, but it's a perfect illustration of the concept of two-dimensional space. In the world of physics and mathematics, 2 dimensions signify a plane. Now imagine a sheet of paper. It's flat and has length and width, but no height, right? That's exactly what a two-dimensional space is. It extends in 2 directions, just like your sheet of paper. You can move forward and backward, left and right, but there's no up or down. You're confined to the surface of the paper. This concept of a plane is fundamental in many areas of study, from geometry to complex algorithms. It's fascinating, isn't it? How such a common everyday object can illustrate a sophisticated mathematical concept. Remember, so a two-dimensional space is like a plane extending in 2 directions. What about the world we live in? Our world is 3-dimensional. An intriguing concept, isn't it? This is the realm we're most acquainted with, the space that extends in 3 directions, forming a continuum in which we exist. This is the dimension that gives depth to our lives. Literally, these 3 dimensions are length, width, and height. Think of it as a box. The length is how long the box is, the width is how wide it is, and the height is how tall it is. Each dimension is perpendicular to the other 2, forming a 3-dimensional space. This is where we live, where we move, where we breathe. We navigate through these 3 dimensions every day of our lives. We climb stairs, we walk through hallways, we dive into pools. All these movements are a testament to our existence in this 3-dimensional space. So, our world is a 3-dimensional space extending in 3 directions. But what if I told you there might be more dimensions than the 3 we perceive? Yes, you heard that right. Beyond our familiar 3 dimensions, length, width, and height, there may be additional dimensions lurking just beyond our reach. Theoretical physics and mathematics dare to venture into this largely uncharted territory. They propose theories that, while difficult to conceive and even harder to observe directly, present a tantalizing possibility. One such groundbreaking theory is string theory. String theory, in its quest to reconcile the seemingly incompatible worlds of quantum mechanics and general relativity, introduces the concept of extra dimensions. It suggests that our universe, instead of being 3-dimensional, is composed of tiny, vibrating strings existing in multiple dimensions. To be precise, superstring theory, a version of string theory, proposes a total of 10 dimensions. That's 7 additional dimensions to the 3 we are familiar with. But why can't we perceive these extra dimensions? Well, one theory is that they're compactified or curled up so small that they're beyond our current observational capabilities. Imagine a garden hose from afar. It appears as a one-dimensional line, but up close you see it's really a three-dimensional object with length, circumference, and the inner hollow. The extra dimensions could be like the unnoticed dimensions of the garden hose. Admittedly, these concepts are mind-bending. They challenge our perception of reality and demand a leap of imagination. We're stepping beyond the comfort zone of our everyday experiences into the realm of the abstract and theoretical. But that's the beauty of science. It constantly pushes the boundaries of our understanding, inviting us to question, explore, and marvel at the complexities of the universe. While we may not have all the answers yet, the journey of discovery is what makes it all worthwhile. So, advanced theories in physics suggest the possibility of extra dimensions that we do not fully understand. Perhaps one day we'll be able to venture into these hidden dimensions, opening up entirely new vistas of understanding. Until then, we continue to probe, ponder, and push the limits of our knowledge. Let's summarize what we've learned about dimensions. When we ponder on dimensions, it's like embarking on an intriguing journey, starting from the simplest form and extending into the complexities of theoretical physics. We began our exploration with zero dimension, which is represented by a point, a location in space that has no extension in any direction, a mere dot. We then moved on to the first dimension, which is represented by a line. This line extends in a single direction, like the path you walk on, or the stroke of a pen on a paper. It has length, but no width or height. Next, we ventured into the realm of two dimensions. A plane, like a sheet of paper or a flat screen, represents this. With length and width, it has extension in two directions. This is the world of your favorite cartoons, where everything exists on a flat surface. Then we stepped into our familiar territory, the third dimension. This is the space we live in, a world with length, width, and height. It is the dimension that gives objects volume and allows us to move in all directions, forward and backward, left and right, up and down. But the universe, as we've discovered, doesn't stop at three dimensions. Theoretical physics and mathematics propose the existence of higher dimensions, dimensions that go beyond our everyday perception. These are dimensions that we cannot directly observe or conceive, but are integral to advanced theories like string theory. These higher dimensions, though elusive, help us understand the complexities of the universe and the mysteries that our three-dimensional perspective cannot solve. They are a testament to the fact that our understanding of the world and the universe is ever evolving. And there's always more to learn, more to discover. So, when someone asks, how many dimensions exist? The answer is not as straightforward as it might seem. It's a question that invites exploration, curiosity, and a deep dive into both the tangible world we experience every day and the intangible realms proposed by theoretical physics. So, the answer to the question of how many dimensions exist depends on the context and the field of study. It's a journey of understanding that begins with a simple dot and travels beyond the boundaries of our three-dimensional world into the fascinating realm of higher dimensions.